Now that we've looked at the main elements of the grammar of graphics, let's see how to do some fine-tuning by looking at a number of the specific tweaks we can make. Note that we'll not be able to look at every possible tweak, so I recommend that the cheat sheet become a frequent companion. Let's start with smoothing in the stat layer. You may encounter situations where you just want to show the curve and not the points. The geom point and stat smooth layers are separate, so you can do this. Notice all I've done is removed the geom point. Here it is as a linear model. The shaded area is the confidence interval for predictions. By default, it's set at 95%. If we do repeated sampling, we expect 95% of our intervals to be in the shaded region. We can change the level of confidence. Here I've changed it to be 70%. And notice what happened is that we get a much narrower band because we're not as confident. We can also eliminate the confidence interval altogether. I've done that here by setting the standard error equal to false to not show it. Let's go back to our original graph. If you've ever taken my experimental design class or any experimental design class, you probably learned about trend analysis, in which we can look at different types of trends: linear, quadratic, cubic. I'm going to look at a quadratic trend by indicating that my response variable should be a polygon that's a function of x, but it's going to be of second order. And this is what I get. So instead of a linear trend, I'm looking for a quadratic trend. I found a post online by someone who had created a user-defined function using ggplot. Check it out. Let's call this function. They called it ggplotRegression. We're going to call this function. We're going to get a linear model for highway displacement and using our miles per gallon. That is highway as a function of displacement. So very simple arguments here, but let's see what this ggplotRegression does. Look at that. It gives you the scatter plot. It gives you a linear regression line with a confidence band. Up here, it tells you what your adjusted R-squared is, your intercept, your slope, and your p-value. Pretty cool, huh? I'll leave it to you to start dreaming about the possibilities. Let's spend a moment talking about inheritance. I mentioned that the only global inheritance is from the ggplot function, so let's see how that knowledge can influence our plots. So here I am back at the original, but I'm going to put in standard error equals false in order to suppress getting a confidence region. Okay, there it is. Now let's move the color aesthetic to become global. Interesting. So what it does at that point, because we've made it global, is that when we do a smooth, the color class is going to be applied to smooth as well. And so rather than getting one regression line through all the points, we're getting regression lines through each class of points. Do you understand that? Do you see what I'm saying? So really another way I could have done this is to take the color equals class here and added it to the stat smooth. It would have been the exact same thing. I would have gotten the exact same thing of what I just got. Because taking and putting color class global means it applies to everything. It applies to the geom point and it applies to stat smooth. So I'm not sure that that's what we wanted, which we might want to go back to the way we had it originally. But actually there are times when you can take advantage of this. So let's look at using this feature to check for interaction in a regression plot. So let's look at our command here. We're going to use here, I'm subsetting, okay? That's a base R command. Remember I said that you can take base R and mix it with the tidyverse. So look at this base R command. You know how to read this. We're subsetting on miles per gallon, so that class is either pickup or minivan or SUV. In other words, out of all these possible classes that we see over here in the graph, we're going to pull out 3 of them. So we're going to have an aesthetic of X highway, Y city, color class. We're going to put in a geom point, and then we're going to smooth this out with a linear regression. So notice method linear model. We're not going to put in confidence interval, and let's see what happens as a result of this. Okay, so what we end up with is a plot that allows us to look for potential interaction of the relationship of highway gas mileage and city gas mileage with class of the vehicle. So what you're looking at here is whether the relationship that exists between highway and city mileage is a function of the class of the vehicle. When I look at the green and red lines, they look almost parallel, but notice that blue line has a little bit less slope in the SUV, a little bit less slope in terms of how much city mile changes as a function of highway mileage. And I'll see you in the next part, which will be part 11.